This is the IBM PS1 model 2011. In our previous exploration we found out just how limited this machine really is. There's no easy way to add standard ISA expansion cards because it lacks internal expansion slots. Unless, of course, you happen to own the external expansion chassis, which is not exactly easy to find these days. So that leaves us with one very simple question. How do you put a machine like this onto a computer network?
Let's talk about legacy network technology. I'm the Vintage Collector and these are my stories.
The answer is this: a Xircom Pocket adapter that plugs into the parallel port. While larger portables like the IBM PC Portable or the Compact Portable still had true ISA expansion slots inside, later more compact machines like the IBM PC Convertible did not give you that option, and PCMCIA was nowhere in sight yet to solve that problem. Now, truth be told, for the PS1 model 2011 there is at least another option today. You can get an aftermarket riser card for around $45, which lets you install one standard 8-bit and one standard 16-bit ISA card. But beware that the space is tight. Most 16-bit cards will collide with the 3.5-inch floppy drive, so you'll have to mostly stick to 8-bit cards or remove the floppy disk drive otherwise. But for today we will have a closer look at this Xircom Pocket adapter. This one in particular is the PT2-16BT, a token ring network adapter which comes in handy because I recently built a token ring network. Of course, Xircom also offered similar pocket adapters for Ethernet. And Xircom was not the only company in this market. Similar parallel pole network adapters were also offered by companies like Acton, D-Link, Realtek and other vendors. As for the P216BT, this one comes with the token ring typical DE9 connector and also barrel jack for external power. My unit came with a UK power adapter which is not especially useful to me. But I found a matching one with a Swiss plug in my parts stock and of course labeled it, because otherwise I will definitely forget what it was meant for. According to ardenttool.com, some of these adapters also came with a pass-through cable which could steal power from the PS2 keyboard or mouse port. But I consider running it from an external power supply the safer choice anyway. One interesting detail is this red rubber band. It can be rotated around the adapter, which retracts or extends the mounting screws into the posts, so you can fix or loosen the adapter on the parallel port. That being said, I had to go scouting for the correct drivers for this unit. Had this been the Ethernet version, that probably would have been easier, but locating the actual token ring drivers took a bit more time. Eventually though, I found the correct driver package. The driver package also contains the TR test utility, and at this point it reports a lobe test error, which is expected because the machine is not yet connected to the token ring network. But it also reports something else that is important. The parallel port is currently running in non-bidirectional mode, and on the IBM PS1 that is the default. Luckily, there is a small utility here called bpp.com which can enable bidirectional mode on this machine. That matters because in non-bidirectional mode you should not expect more than maybe 30 kilobytes per second. With bidirectional mode enabled, this already improves quite a bit to around 80 to 100 kilobytes per second, maybe a little more depending on the raw processing power of the machine. The best performance is possible on systems with EPP or ECP parallel ports. There, real-world transfer rates can reach something more like 400 to 600 kilobytes per second. In theory, EPP can peak at around 2 megabytes per second, while ECP can peak at around 2.5 megabytes per second. That would be 16 and 20 megabits per second respectively. So at least on paper, the faster parallel port modes are in the same range as the 16 megabit token ring specification. But on a machine like this, with an older parallel port and a 286 processor, the practical limit will be much lower. So I relocated the machine to my little museum room where I had previously installed the token ring network. Since I currently run the ring at 16 megabits, I reconfigured the adapter to match that speed, even though I obviously will not reach that throughput here. And now that the machine is connected to the ring, you can hear this gentle ticking. Those are the relays inside the MAU, the multi-station access unit, basically the token ring hub, opening and closing the ring whenever the interface is brought up or down by the test program. So far, so good. Then I hacked up a small batch file to see if I could get this parallel port adapter running with TCP/IP. Because if you have seen the previous episode, you know that my token ring network currently runs on TCP/IP. The batch file first calls bpp.com to enable bidirectional parallel port mode. Then it loads lsl.com, which is Novell's link support layer. Next comes TRODI.com, the actual driver for the Xircom adapter. It implements the network ODI interface, which we will look at in more detail in a follow-up episode. For now, it is enough to say that you cannot directly run TCP/IP on ODI. For that, you need a driver that provides the packet driver interface. ODITRPKT is such a driver. It acts as a shim, effectively translating packet driver calls to ODI calls. For this to work, you also need net.cfg. And net.cfg must set the TRODI.com driver to the token ring snap frame type, otherwise TCP/IP will not be able to run on top of it. Only with that setting in place can ODITRPKT act as a bridge between the ODI driver and the packet driver software. Last but not least, I called mTCP's packet tool just to scan for a compatible packet driver interface. At this point, it is mostly a simple diagnostic aid. Then I start mTCP's DHCP client, which should get an IP address if everything works correctly. And apparently it does, well enough to get ICMP replies from my token ring router. So I updated my TCP/IP diagnostics disks accordingly to include these latest changes. And it works surprisingly well enough in fact that I can connect the adapter to this 1986 IBM PC Convertible and get it onto the token ring network as well. But wait, this is where we should really get into the more contemporary network protocols. So we will soon dive into Novell LSL, personal network and the Inter-Network Packet Exchange Protocol, better known as IPX. But that is a story for another time. What about you? Did you ever use a parallel port network adapter, and what was your experience with it? Share your stories in the comments below. And if you enjoy these retro deep dives, consider subscribing or even becoming a channel member. I'm the Vintage Collector, and this was my story for today. Thanks for watching, and see you again next Sunday.